Determining optimal function after a stroke is dependent upon a large number of factors. Mostly, though, you're looking to see where the stroke occurred, which arteries were involved, as well as the extent and time after the insult. Knowing these factors, the therapist is primarily able to anticipate which body parts are going to be involved, as well as start to prevent and start looking at the trajectory of recovery. To do this, we're going to look at initially at where among the homunculus. And in the homunculus, you're primarily looking at the left side, and in that left side, it's looking at the motor area, as well as the sensory area. And what is represented here is a topographical area of the body and the entire brain. So we're really looking at the temporal and the parietal lobes. What you can see is that the face, the hand, and the arm are more so on the outside of the brain, whereas your hip and your foot are more towards the inner surfaces. The next part that you're looking at is really which artery is involved. So if you were to say we had a gentleman who had a left middle cerebral artery, which would be depicted by the yellow area on the map on the bottom, you can anticipate, going back to our homunculus, that the area of the face, the hand, and the arm are more likely to be involved rather than that of the foot and the hand. You can also expect that these areas are going to take much longer when it comes to recovery rather than that of the hand and the foot, and the hip. On the other side, if a person were to come in with a left anterior cerebral artery, which is depicted by the purple area on the bottom picture, you could then sort of anticipate that the foot and the leg would have a greater impact and therefore take longer to recover rather than that of the hand. Lastly, the factor that we're looking at is looking at the time that is elapsed as well as the extent of damage that could be expected. Main thing that we're looking at is the time that is elapsed. Obviously, the greater it is, the more damage can be expected. And the damage that really happens in two specific phases. The first phase, which is the direct mechanical damage, which is ultimately a disruption in the blood flow from either an ischemic stroke, which is happening as a result of, and ultimately creating that, is the direct impairment of blood flow, which increases your membrane permeability. It also increases the metabolic imbalance and then ultimately leads to tissue damage. The second stage is really as a direct result of the physiological processes from the first insult. And in this stage, you're looking at axon terminal depolarization, release of excitatory neurotransmitters, intracellular breakdown, apoptosis, and necrosis. Now, what that primarily means in more simple language is in the area in which the brain has been damaged as a result of the stroke, the nerves are starting to retract and they're no longer communicating with each other in the area. Because the nerves are not working, the tissue cells are not being worked either. And because they're not being worked, they start to die just as a result of normal cell death. But you're also getting an increase in abnormal cell death or just regular cell death, ultimately leaving tissues that are not working the way that they should.